Hello everyone, I welcome you all to my channel. In this video, we are going to see convolution integral by using graphical method. In my previous video, I have explained about the convolution integral. So now just we are going to recall the formula. What is convolution integral? So convolution of two signals is given by y of t equal to x of t convolution h of t. So the formula is integral minus infinity to infinity x of tau into h of t minus tau into d tau. This can also be written as integral minus infinity to infinity x of t minus tau into h of tau into d tau. Next we are going to see what are the steps used for solving the convolution integral problem by graphical method. So first step, for the given signals x of t and h of t, graph the signals x of tau and h of tau as a function of independent variable tau. That means instead of t we have to substitute tau and find out what is x of tau. Similarly, h of t, instead of t we have to substitute tau and find what is h of tau. Then we have to draw the graph for it. Second step is we have to obtain h of minus tau, that is by using the folding property. Then third step is by using shifting property we have to find h of t minus tau. Then fourth step is we have to graph the signals x of tau and h of t minus tau. Then we have to check whether there is overlap or not. Depending upon the overlap only we will be getting the answer. Then the next step is multiply the two signals x of tau and h of t minus tau and integrate over the overlapping interval of two signals to obtain the y of t. So these are the simple steps used for solving the convolution integral problem by graphical method. So let us solve a problem. Find the convolution by graphical method. X of t is given 1 for the interval 0 to 2, 0 otherwise. H of t equal to 1 for the interval 0 to 3 and 0 otherwise. So according to convolution integral, we know the formula y of t equal to integral minus infinity to infinity x of tau into h of t minus tau into d tau. So first we have to see what is x of tau and what is h of t minus tau. So x of t, again we have written x of t equal to 1, 0 to 2 and 0 otherwise. H of t. Now first step, we are going to graph x of t and h of t. So x of t is unit step function, that is for the interval 0 to 2 its value is equal to 1. So for the interval 0 to 2 its value is equal to amplitude is equal to 1. Then h of t, for the interval 0 to 3 its amplitude value is equal to 1. So 0 to 3 amplitude value is equal to 1. This is x of t, h of t. But we have to plot x of tau, h of tau. This is t axis. So step 2, we are going to plot x of tau. So this is x of tau. Instead of t, we have changed it as tau. This is h of tau. So the next step is we have to plot h of minus tau. So this is our h of tau. Now we have to plot h of minus tau using folding property. Just we are going to fold this signal. So we will be getting h of minus tau means just the mirror image of this. So minus 3 to 0, its amplitude value is equal to 1. Then in the next step, we have to find what is h of minus tau plus t. That means we have to add t to the tau axis limits. So here we are having minus 3, then we have to add t to it. So minus 3 plus t. Then 0 here. The another limit is 0. So with this add t. So 0 plus t is equal to t. So you will be getting h of minus tau plus t is this graph. So next we have to multiply x of tau and h of t minus tau. So depending upon the value of t only we can calculate the value of y of t. So first we are considering case 1. That is t is less than 0. So if t is less than 0 means we can assume t is equal to minus 1. So if we substitute t is equal to minus 1 here we will be getting a new limit as minus 3 minus 1 to minus 1. That is minus 4 to minus 1. Now we have to draw this graph. So while drawing this graph there is no overlap between h of minus tau plus t and x of tau. Since there is no overlap, we can write y of t equal to 0. Then case 2. Here we are assuming t value is in between 0 and 2. So 0 and 2 means, let us assume t is equal to 1. So minus 3 plus 1 to 1. So the new limit is minus 2 to 1. Now we have to draw the graph. So first we are plotting x of tau, then h of t minus tau. So you will be getting in between 0 and 2, the first limit, and the second limit is less than 0. So you will be getting minus 3 plus t and t like this. So there is an overlap between x of tau and h of minus t plus tau for the limit 0 to t. Therefore, we can write overlap region is 0 to t, y of t equal to, this is convolution integral formula, integral minus infinity infinity x of tau into h of t minus tau into d tau. So here the limit is 0 to t. Therefore, y of t equal to integral 0 to t into d tau. We have to integrate it, d tau is tau. Then we have to apply the limit 0 to t. So the answer is t. This is the answer for case 2. Next, we are going to consider case 3. So in case 3, the t value is in between 2 and 3. So we can assume t value as t is equal to 2.5. That means minus 3 plus 2.5 to 2.5. So the new limit is minus 0.5 to 2.5. So you will be getting the graph like this. This is your x of tau graph. Then h of minus tau plus t graph will be approximately like this. That is, the t value is minus 0.5 to 2.5. So this limit is 2.5 and this limit is minus 0.5. Now we have to check whether there is any overlap. Yes, here there is overlap between the region 0 to 2. Therefore, we can write the overlap region is 0 to 2 and y of t is equal to integral 0 to 2 into d tau. Since here the amplitude value is equal to 1, so we can write only d tau. Now we have to integrate it d tau, its value is tau, then we have to apply the limit. So answer is 2. So the next case is t is in between 3 and 5. So we can assume t is equal to 4. So minus 3 plus 4 to 4. The new limit is 1 to 4. Now we have to draw the graph. So this is our x of tau. Then h of minus tau plus t. So the limit is 1 to 4. So the lower limit is in between 0 and 2 and the upper limit is greater than 2. So you will be getting the graph like this. Now we have to see the overlap period. So here the overlap period is from minus 3 plus t to 2. Therefore, y of t can be written as integral t minus 3 to 2 into d tau. So after integrating and applying the limit, you will be getting 2 minus t minus 3, that is equal to 5 minus t. Then fifth case, t is greater than 5. So if t is greater than 5 means we can assume t is equal to 6. So the new limit is 3 to 6. So if we draw the graph, this is our x of tau, then h of minus tau plus t. So the lower limit is 3. That means it is greater than 2 and the upper limit is 6. So you will be getting approximately here. So now we have to check whether there is any overlap between x of tau and h of minus tau plus t. Since here there is no overlap, we can write y of t equal to 0. So we can put the answer as y of t is equal to 0 for t less than 0 and t greater than 5. So for both the limits, the value of y of t is 0. Then for t in between 0 and 2, y of t is equal to t. For t in between 2 and 3, y of t value is equal to 2. And for t in between 3 and 5, y of t value is 5 minus t. So I hope you have understood the problem how to solve convolution integral using graphical. So if you like this video, kindly subscribe my channel and share with your friends. Thank you.